Hi, this is Dr. R. Karthik, and in today's lecture series of control system, we are just going to discuss about the block diagram and block diagram reduction. So, any control system can be represented in a pictorial representation in terms of blocks for easy understanding and analysis. So, one such method we call it as the block diagram. Now, block diagrams, they consist of a single block or a combination of blocks, and they are mainly used to represent the control system in a pictorial form for easy understanding. Now, signal into the block, it represents the input R of S, and the signal out of the block represents the output C of S, while the block itself stands for the transfer function of the system. Now, here in block diagram, the signal flow is unidirectional. That is, it can flow only in one direction. So the output being equal to the input multiplied by the transfer function of a block. Now, the simple elements of a block diagram is just shown in the diagram. Now here you can see, now R of S, it is the input of the system, and C of S is the output of the system, and G of S is the plant transfer function, and here it is a closed loop system, so we have H of S as the feedback transfer function. And here you have a summing point which adds up two signals, and then we have a takeoff point where the same signal is fed back into the circuit to some other point. Now this forms the basic elements of the block diagram. Now, as discussed in the introduction, now I can see the signal flow is unidirectional, now where it flows from the input to the output. So X of S is the input, Y of S is the output, and G of S is the plant transfer function. Now therefore the output Y of S is equal to, it is the transfer function multiplied by the input of the, that is the input signal. So we get this particular answer. Now the next element that is used to represent the block diagram is the summing point, which is used to add up or that is compared to signals. Now here you can see, now we have two signals A and B. Both are added together in order to give a single output signal, whereas here in this case A is subtracted with B in order to get the single output signal. So these are few basic elements of a block diagram. Now how to go with, now if the system gets complicated, that is the control system, the block diagram also gets complicated, so hence determining the transfer function is a very difficult task. So therefore, in order to have that is the complete block diagram, now we have certain techniques in order to reduce the block diagram. Now you call it as the block diagram reduction. In short, it is BDR, it is block diagram reduction. Now here, what all we can do, now we can reduce the blocks which are connected in series, that is called as the cascading of blocks, and we can also reduce parallel blocks, that is feed forward blocks or feed forward paths. And then we can reduce minor feedback loops, that is small feedback loop, one single signal fed back into the loop. And also it is possible to shift the summing point to the left and takeoff point to the right or left and vice versa. And we can repeat all the above steps so that we get a simple final block diagram. The transfer function can be easily determined. So we have 6 such rules. Which is not, that is, it is not just like a formula, it is a rules. It is applicable based on the condition and based on the what you call as the complexity of the block diagram. So the first rule, you call it as combining blocks in cascade. Now you can see we have two blocks which are connected in series. So we can say it as connected as series because the input signal is the same for G1 and G2, and we have an output signal. So here in this case, now these two blocks can be reduced into a single block, that is multiply the two transfer functions, and the output, as we know, it is the transfer function multiplied by the input signal. So this is the first basic law for the block diagram reduction. It is cascading blocks. The second one is combining blocks in parallel or eliminating feed forward path. Now the basic difference between a feedback path and a feed forward path, here you can see the signal is fed forward to the in the diagram or in the block diagram. So here in this case, the transfer function g1 and g2, they can just be simply added or subtracted based on the signal which is added or subtracted. So here cascading, we multiply two blocks, that is two transfer function, and combining parallel blocks, we just add or subtract two signals. Now in any case, now you can see the output in both the cases, that is the original block diagram and the equivalent block diagram, it remains the same. The next important thing is moving a pickoff point behind a block. So this we call it as a pickoff point or a branch point. Now we move it behind this block G. Now in this case, now your transfer function, that is the feedback, you have to multiply it by 1 by G so that the output remains the same. The output, it remains the same. And the next one is moving the branch point before or ahead of the block. So here in this case, now your transfer function is just, that is the feedback, it is just multiplied by G. In previous case, it is 1 by G, and in this case it is just G. So even if you reduce the output, it remains the same. And the next rule, it is moving a summing point behind a block. So here you can see the summing point is moved behind a block, and similarly the summing point is moved ahead of a block. And then the final and very important one is the feed, that is eliminating a small feedback path. Now the closed loop system, it can be eliminated, and the final transfer function, it is given by that is our C of S by R of S is equal to, so our C of S by R of S is equal to, I'll just write it. So our C of S by R of S. R of S for a feedback path, a small feedback loop, it is equal to, it is G of S divided by 1 plus, it is G of S into H of S. So here the feedback loop is eliminated into a single block given by G of S divided by 1 plus G of S into H of S. Now these are the 7 rules, basic rules for reducing a block diagram in order to get the final transfer function. So that's it for today. Thank you very much.